They designed the Panther to be the answer to a nightmare, a technological response to the shock of 1941 when German tank crews first watched their Panzer III and Panzer IV rounds bounce uselessly off the sloped armor of the Soviet T-34. The Eastern Front had revealed a brutal truth. Germany's armored doctrine was being outpaced by a faster, more mobile, more survivable enemy tank, and unless the Wehrmacht produced something radically superior, the initiative in armored warfare would slip away forever. In late 1941 and early 1942, German engineers scrambled to design a new medium tank that would combine firepower, mobility, and protection in a single machine. The result was the Panther, a tank intended to be the future of the Panzerwaffe, a vehicle that blended German engineering sophistication with the lessons learned from the T-34. It had thick, excellently sloped frontal armor, a long-barreled 75mm KWK-42 L-70 cannon capable of destroying Soviet armor at ranges beyond 1 kilometer, wide tracks for improved mobility, and a silhouette that suggested lethality from every angle. On paper, Germany had built a masterpiece, but the Panther was born into a war that no longer cared for perfection. It cared for readiness, it cared for numbers, and above all, it cared for reliability. None of these were strengths the Panther possessed in 1943. The tank's development was sped through every stage because of one looming deadline: Operation Citadel, Hitler's summer offensive against the Kursk salient. Instead of allowing months or years of testing, Germany rushed the Panther from drawing board to assembly line and then directly to the Eastern Front in barely half the time required for a major armored platform. Factory modifications continued even as vehicles were being loaded onto trains. The crews received tanks that had never completed proper field trials. Manuals were unfinished, replacement parts were scarce, mechanics were inexperienced. What rolled into the forests west of Kursk in June 1943 was not a mature weapons system, but an experimental platform forced prematurely into the largest armored clash in history. The consequences were immediate and devastating. Panther crews who had trained on older Panzers suddenly faced a machine far more complex and temperamental than anything they had operated before. Even basic driving maneuvers strained the transmission. The Maybach HL-230 engine, powerful but fragile, overheated easily. Seals leaked, fuel lines cracked. The torsion bar suspension, innovative but untested, failed under the stresses of field use. The Panther's high weight far exceeded what German engineers had originally planned, and no one had redesigned the drivetrain to compensate. The result was a vehicle that demanded perfect maintenance and ideal operating conditions in a war where neither existed. Commanders in Brigade 10 and Panzer Regiment 39, the first major units equipped with Panther Ausf D tanks, watched in disbelief as their new super tank began failing before the battle even began. During the march toward the assembly areas, dozens broke down, engines caught fire, gearboxes seized. Tanks had to be abandoned or towed before firing a single round. Reports sent back to OKH described a catastrophic readiness rate, but the operation could not be delayed. Hitler was convinced the Panther would be the armored spearhead that crushed the Soviets at Kursk. The Reich had invested prestige, propaganda, and strategic hope in this machine. It had to fight, ready or not. Crews painted numbers on tanks that could not move. Maintenance teams worked through entire nights cannibalizing parts from already dead Panthers just to make a fraction of the force operational by July 5. Even then, the technical disaster continued. Many Panthers entered the battle with engines prone to fire and transmissions that could fail at any moment. They rolled forward alongside Tiger 1s and Panzer 4s that, while less impressive on paper, were at least dependable. The contrast foreshadowed everything that would follow. The Panther was meant to be the tank that restored German dominance on the Eastern Front. Instead, it entered the war as a symbol of something more complicated, a brilliant design trapped inside a rushed, unreliable machine. In 1943, its potential was undeniable, but so was its fragility. And as the opening shots of Operation Citadel drew near, the German High Command was about to discover that a weapon's theoretical strength means nothing if it cannot survive the battlefield long enough to use it. The men who crewed the first Panthers knew they were driving a weapon that looked unstoppable, but they also knew, often within minutes of climbing aboard, that something was deeply wrong. Even before a single Soviet gun fired at them, the Panthers of Panzer Regiment 39 were already dying on their own. What the German High Command had envisioned as a decisive armored fist was, in reality, a formation built on fragile mechanical foundations, and those foundations began collapsing the moment the unit started rolling toward the front. The Panther's most dangerous flaw lay inside its heart, the Maybach HL-230 engine. Designed originally for lighter vehicles, the HL-230 was pushed far beyond its intended limits to power the 45 to 48-ton Panther. During factory trials, brief, controlled, and unrealistically gentle, it performed adequately. But in field conditions, with dust, mud, and long marches at combat speed, the engine overheated catastrophically. Oil leaks were common, fuel lines ruptured, fires ignited beneath the engine deck with alarming frequency. Mechanical crews soon learned to associate the smell of burning oil with the Panther's arrival. The transmissions were no better. The Zonrad Fabrik AK-7200 gearbox was a sophisticated but delicate piece of engineering, completely unprepared for the stresses of sudden acceleration, off-road shock loads, and emergency braking on the uneven Eastern Front terrain. Under real combat strain, gears locked up or shattered. Panthers froze mid-march, unable to shift out of low gear. Others would stall abruptly, leaving the crews stranded and helpless. Within days, transmission failures became so routine that maintenance officers began cannibalizing one Panther to save two others. Then came the suspension problems. The Panther employed a complex torsion bar suspension, impressive in theory and excellent for cross-country mobility, but extremely sensitive to manufacturing flaws. Under rushed wartime production, quality control faltered. Torsion bars cracked, road wheels sheared, idler arms bent under the tank's weight. Often, a single torsion bar failure immobilized the entire vehicle, and replacing it in the field was nearly impossible without full workshop facilities. Even the fuel system was a hazard. The Panther's fuel pumps and lines were poorly shielded, and vibrations frequently caused fittings to loosen, producing leaks that dripped onto hot engine components. The result was spontaneous fires, sometimes while the tank was stationary. Crews joked darkly that their tanks were more likely to kill them with smoke inhalation than Soviet shells. All of these mechanical weaknesses interacted with a final, devastating problem. The Panther was rushed into service without sufficient testing, spare parts, or trained mechanics. Many crewmen assigned to Panther units had only a few days of familiarization training. They had never performed major repairs, didn't know which noises signaled impending failures, and often tried to apply Panzer IV procedures to a tank that obeyed no familiar rules. Maintenance teams, already stretched thin, were overwhelmed by breakdowns. Spare parts were so scarce that crews regularly stripped panels, road wheels, and entire engines from wrecked Panthers, simply to keep a handful of vehicles operational. By the time Panzer Regiment 39 reached its assembly areas near Kursk, the scale of the disaster was plain. Out of the 200 Panthers assigned to XL-48 Panzer Corps, nearly half were already non-operational. The numbers staggered German officers who had expected a powerful armored strike force. Instead, they had inherited a logistical nightmare. And the nightmare grew worse when Operation Citadel finally began on July 5, 1943. On the very first morning, as the Panthers advanced through minefields and heavy terrain towards Soviet positions, the mechanical failures multiplied. Engines burst into flames, gearboxes seized, cooling fans failed. Many Panthers never even reached the first line of Soviet defenses. They died on the approach march, their destruction recorded not in enemy action reports, but in maintenance logs filled with technical failures. Incredibly, more Panthers were out of action on July 5th due to mechanical issues than from Soviet fire. Reports from XL-48 Panzer Corps revealed the brutal truth. Over 45% of all Panthers were immobilized within the first few days, most without ever firing their main gun. For a tank designed to dominate the battlefield with its powerful KWK-42 L-70 gun, failing to survive long enough even to engage the enemy was an indictment of the entire Panther program. The German High Command had demanded a miracle weapon. What they received was a machine that looked like a miracle but behaved like a prototype. The Panther's greatest weakness was not Soviet armor or artillery, it was itself. And that fragility would haunt every battle the Panther fought from Kursk until the end of the war. Operation Citadel was supposed to be the Panther's triumphant debut, the moment Germany's newest, most advanced medium tank would spearhead a decisive breakthrough and restore the Wehrmacht's momentum on the Eastern Front. Instead, Kursk became the battlefield that exposed, in the harshest possible way, the gap between the Panther's promise and its reality. When the offensive began on July 5, 1943, the Panther regiments of XLVI Panzer Corps rolled forward alongside Panzer IVs and Tigers toward the fortified Soviet positions around the southern face of the Kursk salient. But even before they reached the first defensive belts, Panther crews were already fighting a three-front war: the Red Army ahead of them, the boggy terrain beneath them, and the tank's unreliable mechanics inside every steel plate and gearbox. On paper, the Panther's strengths were undeniable. Its sloped 80mm frontal armor made it nearly invulnerable from the front to most Soviet anti-tank guns. Its 75mm KWK-42 L-70 cannon could destroy any Soviet tank, including the T-34 and KV series, well beyond 1,500 meters. In open country with room to maneuver, the Panther had the potential to dominate. But Kursk did not offer the Panther open fields or maneuvering space. It offered minefields, mud, anti-tank ditches, and Soviet defenses layered to a depth unprecedented in the war. Worse, the Panthers entered the battle already battered. Of the 200 deployed, barely 180 were operational at dawn on July 5th. And almost immediately, the Soviet minefields inflicted a fresh wave of casualties, not through combat, but through shock damage. When Panthers hit mines, even those not penetrated suffered broken torsion bars, shattered road wheels, and cracked engines from the violent impact. The tank's suspension, still flawed from rushed production, simply could not tolerate the punishment. Many Panthers disabled by mines were not destroyed. Their armor held, their guns were intact, but their mechanical systems failed catastrophically, leaving tanks stranded in no man's land, often under Soviet artillery fire. What followed was a collapse in combat readiness that stunned even the most hardened German officers. By the end of day one, only 40 to 50 Panthers remained fully operational. Others sat crippled behind the lines with overheated engines, failed transmissions, or broken suspensions. Some had burned due to fuel line fires. Panzer Regiment 39, which was supposed to be the cutting edge of the Kursk assault, now resembled a shattered unit that had endured weeks of attrition after only a few hours of fighting. For the Panthers that survived the opening push, the battle was far from over. Those that reached effective firing positions finally demonstrated the raw killing power of the KWK-42 L-70 gun. Soviet T-34s that attempted to counterattack were cut down at extreme ranges. In tank-on-tank engagements, the Panther was frightening. It struck with precision, penetrated with ease, and could reliably kill before the enemy even closed into effective firing range. But these tactical successes could not compensate for the strategic failure of the machine itself. The Panther could win duels, it could not survive the campaign. The deep Soviet defensive belts required continuous momentum. Units had to push through one obstacle into the next before the Red Army could regroup. But the Panther units, crippled by mechanical losses, simply could not maintain the operational tempo required. Entire companies dwindled to fewer than 5 running tanks. Recovery crews were overwhelmed. Repair teams worked non-stop, often stripping 10 disabled Panthers to get one running again. Even when Panthers were repaired, many returned to battle only to break down again hours later. Some never left the repair depots at all. Meanwhile, Soviet forces quickly learned that immobilized Panthers, even undamaged, were easy targets. Artillery fire could finish what mechanical failure had begun. Infantry with anti-tank rifles and grenades could swarm abandoned vehicles. The battlefield was littered with burnt-out hulks that had scarcely fired a shot. By July 10th, barely 5 days into Citadel, the disaster was undeniable. Over 45% of all Panthers had been lost to mechanical breakdowns, fires, or immobilization,
not Soviet guns. The German high command faced a painful truth. The Panther's lethality meant nothing if the tank could not move, advance, or even start its engine. Kursk was supposed to be the Panther's proving ground. Instead, it became the battlefield that proved the Panther was not ready for war. It was a weapon of extraordinary theoretical strength and catastrophic practical weakness. And although later Panthers would improve dramatically, the stain of their first battle never completely faded. In July 1943, the Panther had shown the world exactly what it was, the Panther that could win any fight except the one against its own machinery.
In the aftermath of Kursk, Germany faced an uncomfortable reality. Its newest and most advanced medium tank, intended to dominate the Eastern Front, had instead revealed itself to be one of the most fragile armored vehicles ever fielded by the Wehrmacht. But unlike many failed wartime designs, the Panther did not remain broken. Throughout late 1943 and 1944, German engineers worked relentlessly to redesign, reinforce, and refine the machine. As the Ausf D gave way to the Ausf A and later the Ausf G, the Panther underwent a transformation from a deeply unreliable prototype into a battlefield predator that, on an individual basis, was arguably the best medium tank of the war. And yet, even at its best, the Panther could never escape the shadow of its origins. Every improvement arrived too slowly, too late, and in too small numbers to change Germany's strategic fate. The first wave of corrections targeted the Panther's most notorious flaws. Engine fires, so common at Kursk that some crews joked their tanks were self-igniting, were addressed by redesigning the fuel lines, improving insulation, and adding fire suppression systems. The transmission, prone to catastrophic failure under stress, received stronger gears and reinforced housings. The cooling system was overhauled to better manage the heat produced by the Maybach HL-230 engine. These changes significantly reduced the Panther's tendency to overheat or burst into flames during long marches. The suspension system also saw improvements. Torsion bar failures became less frequent as metallurgical quality rose and machining tolerances tightened. Road wheels were strengthened. The idler wheel design evolved to better distribute weight and reduce strain. Even the armor layout was refined. The mantlet of the Ausf G was modified to eliminate the shot trap that had allowed deflected rounds to penetrate the hull roof. These upgrades mattered. In the field, later Panthers were far more dependable than their Kursk ancestors. Crews began to trust their machines again. Reports from 1944 Panzer divisions fighting in Normandy described Panther units achieving readiness rates far higher than those seen the previous summer. In combat, the Panther's strengths were undeniable. Its gun remained one of the most deadly anti-tank weapons of the war. At long range, it outshot Shermans, Cromwells, and even many Soviet heavy tanks. Its frontal armor, still effectively immune to most Allied medium tank guns, allowed it to dominate open engagements. Panther crews, especially veterans, feared no opponent in a frontal duel. The problem, the fatal flaw, was that the battlefield of 1944 was no longer a realm of controlled duels. The war had shifted decisively toward mobility, logistics, and combined arms. And in this environment, the Panther remained profoundly ill-suited, regardless of how much its mechanical reliability had improved. First, the Panther was still too complex. Its engine, suspension, and transmission were maintenance-heavy even after redesigns. Compared to the Sherman or the T-34, which could be repaired in the field by modestly trained crews, the Panther demanded workshops, cranes, spare parts, and skilled mechanics, resources Germany increasingly lacked as the war dragged on. Second, the Panther was too expensive. Its cost and production time were significantly higher than those of the Panzer IV, yet Germany's industrial base was shrinking under Allied bombing. Even at peak production, Germany could never field Panthers in the quantities required to match Allied armored numbers. Third, the Panther was too fuel-hungry. By late 1944, the collapse of Romanian oil supplies crippled the Wehrmacht's ability to sustain armored operations. Many Panthers that might have fought effectively were instead abandoned for lack of fuel or used as static defensive guns. Fourth, the Panther was too heavy for many operational environments. Its weight strained bridges, bogged down in forests and marshes, and restricted maneuverability in the tight bocage fields of Normandy. It excelled on dry, open ground, but the war no longer gave Germany the luxury of choosing where to fight. Finally, the Panther arrived too late. Its improved variants entered service at a time when Germany was being ground down on all fronts. Even the most advanced tank could not compensate for overwhelming Allied air superiority, dwindling supplies, or the collapse of German strategic mobility. Thus, the Panther, for all its battlefield brilliance, never became the war-winning weapon Germany needed. It fought hard in Normandy, in the Ardennes, in Poland, and across the collapsing front lines of 1945, but it always fought outnumbered, undersupplied, and perpetually struggling against reliability issues that, though reduced, never disappeared entirely. The Panther had finally become the tank it was meant to be, but the war Germany built it for had already slipped irretrievably out of reach. In the end, the Panther became a symbol of the fundamental contradiction at the heart of Germany's war effort. A nation obsessed with engineering brilliance, yet increasingly incapable of sustaining the industrial, logistical, and operational systems needed to support such brilliance. The Panther was not simply a tank. It was a microcosm of the Reich's strategic failure. It promised everything, delivered too little, and demanded far more than Germany could afford to give. Even in its improved Ausf A and Ausf G forms, the Panther never solved the crisis that defined its existence. The gap between what it was designed to do and what it could realistically achieve in a war that had become defined by numbers, reliability, and speed of deployment, not individual battlefield superiority. For Germany, the Panther was intended to correct the imbalance created by the T-34 in 1941. But the problem was no longer technical, it was strategic. By 1943-44, the Wehrmacht no longer needed a tank that could win duels. It needed a tank that could be built fast, maintained easily, fueled reliably, and fielded in vast quantities. The Panther was none of these things. It was too heavy for rapid production, requiring specialized steel, precision machining, and long factory times. Every Panther built consumed resources that could have produced 2 Panzer IVs or several Stug 3 assault guns, vehicles that, unlike the Panther, could reliably remain operational for months. Germany's industry was collapsing under Allied bombing, but the Panther program continued to demand materials and manufacturing tolerances better suited to peacetime. This created a bottleneck. The Wehrmacht needed tanks immediately, but the Panther production lines delivered them slowly and unevenly. Even the Panthers that reached the front did so with logistical chains that were no longer functional. Panther transmissions and final drives still suffered high failure rates. Engines remained sensitive to dust and overheating. Fuel consumption was extreme, grounding many tanks during critical operations. Spare parts were scarce. Field depots cannibalized dozens of Panthers simply to keep a handful running. And while Germany's armies were bleeding experienced mechanics and tank crews, the Panther required the most skilled personnel to keep it alive. The tank's complexity was an asset on the factory floor, but a liability in a battlefield workshop staffed by teenagers and undertrained replacements. Strategically, the Panther also struggled to fit into Germany's changing war doctrine. Early war blitzkrieg relied on speed, maneuver, and massed armor. But late in the war, Germany increasingly fought defensive battles where mobility was limited and supply lines disintegrated. The Panther excelled at long-range duels, but struggled in cities, forests, and close-range ambush conditions, precisely the environments Germany increasingly found itself fighting in from 1944 onward. The tank's wide profile and high silhouette made it hard to conceal. Its fragile sides were vulnerable to infantry anti-tank weapons. In the Bocage country of Normandy, Panthers were often ambushed by Shermans, Cromwells, and Allied tank destroyers, firing into their thin flanks from 50 to 100 meters. The Panther's theoretical strengths mattered less and less in the actual conditions of the battlefield. Yet even beyond tactical and logistical constraints, the Panther's greatest flaw was that it solved a problem Germany no longer faced. In 1943, the Wehrmacht's true enemy was not the T-34, it was attrition. And attrition could not be defeated with a single superior machine. It demanded an industrial base capable of producing thousands of functional, dependable vehicles. The Allies understood this principle. The United States built Shermans by the tens of thousands, reliable, standardized, easy to repair. The Soviet Union built T-34s in factory-like quantities, unrefined but mechanically forgiving. Germany built Panthers, individually impressive but strategically irrelevant. By 1944-45, Panther battalions rarely reached full strength. Many tanks were left behind during retreats due to mechanical failure or lack of fuel. Others were destroyed by Allied air power before they ever engaged in combat. A tank that could not move, could not be supplied, and could not be repaired was not a battlefield asset. It was a liability. Thus, the Panther, a tank conceived as a technological counterstrike, instead became a monument to wasted potential. Its gun was exceptional, its armor was formidable, its design was forward-thinking, but none of that mattered when its transmission failed, when its engine overheated, when its weight overwhelmed bridges, when its parts ran out, and when its fuel tanks went dry. In the end, Germany's best tank was also its most fragile, not because of what it could do, but because of everything it demanded from an army and an economy that were collapsing around it. It was a weapon out of step with the war it was born into. The Panther never failed in combat. It failed in reality.